Good morning, one and all. This is Padmavati from Department of Computer Science and Engineering in Sri Venkateshwara College of Engineering. Today we are going to discuss a topic on digital image processing, and our today's topic is region splitting and merging. As I have already discussed one of my video, region growing. This is the reverse technique of the region growing process. Let's enter into the topic. Let's see. For example, you have a R. R represents the entire image region. We need to select a predicate value. Once the approach for segmenting R is to subdivide it successfully into smaller and smaller quadrant regions. For any regions, Ri is the predicate of your region, which is always true. So we start with entire region. If P of R is false, then we divide the region, that is image, into quadrants. If P is false for any quadrant, we subdivide that quadrant into subquadrants and so on. And here we use a process called quadtree, where quadtree is a tree in which nodes have exactly 4 descendants. See, 4 descendants in the sense it has 4 subdivisions. My image is R and I'm partitioning it into 4 parts, which is called as R0, R1, R2 and R3. Then it is called as a quadtree. And as we all know, quad represents 4. So R is divided into 4. So when it is divided into 4, it is called as quad, and I'm dividing it in the form of tree. So it is called as quadtree. And here the variance is very large. So as we have seen in region splitting, so what here in this figure you can see R is divided into R0, R1, R2, R3. And here I want to divide again R1. So that R1 is divided into R10, R11, R12 and R13. And whenever you take an image, the image will be divided into four features or 4 components. The first component is approximation, horizontal, vertical and diagonal coefficients. So that is called as, we can call it as A, H, V and D, where A is called approximation, H is called horizontal, V is called vertical and D is called the diagonal coefficients. So if I segregate R, see this is the entire image R. I'm partitioning it into 4, R0, R1, R2 and R3. And again I want to split this R1. So what happened to R1? R1 is also again splitted into 4. R01, R11, R12 and R13. And again, if I want to split, for example, if I want to split again R12, then it is divided into R120, R121, R122 and R123. So likewise, the splitting process will goes on equally. And whenever I'm splitting an image, as I have told, it is divided into 4 components: approximation, horizontal, vertical and diagonal. All the features of the image will be transferred into the approximation coefficient. So the detail of the image can be segregated using the approximation coefficient. So here we can see the approximation holds the area of R0. And here in this part, the approximation coefficient transferred to R01. So whenever you take an image, the top left will be the approximation coefficient and the right side will be your horizontal coefficient, and the bottom left will be your vertical coefficient and bottom right will be the diagonal coefficient. Then we'll move on to region merging. So what is region merging? It is nothing but the reverse process of your region splitting. So as I have split the region, again I need to merge it. And I'll just explain you in the form of flow chart. First, you need to take a input image. Then you need to check the predicate condition. If the condition is true, then the condition depends on what you fix. suppose if I fix, it is a splitting image. If I fix my true condition as my merging, and if the condition is true, then the images will be merged. Suppose if the condition is false, then the images will be splitted and it is moved to stop condition. And you can calculate all these things using histogram also. And using this, you can quantify the texture of a region and the concept of texture segmentation, which is based on using the measure of texture for predicates P of Ri. And here you can perform texture segmentation by various method you can use. And some of the various methods are morphological watersheds and watershed segmentation algorithms and dam construction and all. These are the various topics where you can use. And in morphological segments, you can have catchment basin and watershed, which has a minimum values, and the entire image has been splitted or merged. So here ends the topic of splitting and merging. And we have seen the quadtree decomposition also. And all those things here, pixel plays an important roles in an image, which are all similar, it leave as it is, and which is not similar, it is splitted or it is merged. And if you break the image into quadrants, then or it is called as 4 partitions, then it is called as a quadtree, where R is your image and R is divided into 4, R0, R1, R2 and R3. And for your entire image, the variance is very large. Hope you understand the concept. Thank you.